Welcome to today's Explainer, where we're going to completely redefine how we look at brain healing. We're actively transforming our understanding of stroke rehabilitation from what has historically been a bit of a guessing game into a highly precise, data-driven science. We're diving into some truly groundbreaking research that is fundamentally changing the entire landscape of neurology.
All right, let's jump right into Section 1, the stroke recovery paradox.
So why on earth do identical strokes heal so differently? It's literally the central medical mystery of this field. Researchers in Finland recently did a prospective comparative cohort study with 169 ischemic stroke patients, and they highlighted a really frustrating reality. You can have two patients suffer nearly identical brain lesions, yet they end up with wildly different functional outcomes. One might make this remarkable recovery, while the other remains with significant disability, even when given the exact same treatment. Crazy, right?
And look, this unpredictability isn't just some abstract academic puzzle. In Finland alone, a country that sees roughly 18,000 new stroke cases a year, this post-stroke disability creates a massive economic burden. We're talking over 1.1 billion euros annually when you combine direct medical costs and lost productivity. That is a staggering number. So solving this paradox is absolutely critical, both for human lives and for our healthcare systems.
Moving on to Section 2, unlocking neuroplasticity and the brain's incredible adaptability. The missing link to this whole recovery paradox? It's a fascinating biological process that happens right inside the brain immediately after an injury. It proves a fundamental truth: the brain isn't static. Through neuroplasticity, it's highly adaptable and can literally rewire itself around the damage. It's like a biological detour. But the catch is that how efficiently it adapts varies dramatically from person to person.
Within hours or sometimes weeks after a stroke, surviving neural circuits trigger these very specific, honestly amazing cellular events to rebuild connections. You get synaptic remodeling, axonal sprouting, even limited neurogenesis from endogenous progenitor cells. But the absolute star of the show here is that first bullet point, the upregulation of neurotrophic factors.
Looking at the data from those 169 Finnish patients really hits the nail on the head. A surge in brain-derived neurotrophic factor, or BDNF, was the ultimate marker of a brain successfully repairing itself. It was the primary mechanism in nearly 33% of patients. And get this, the vast majority of those specific patients achieved good or even excellent functional recovery. BDNF is the central orchestrator here, for sure.
Which brings us to Section 3, magnetic brain stimulation.
So if BDNF is the golden ticket to recovery, the next logical step is figuring out how to actively boost it. No more crossing our fingers and passively waiting. We're talking about a massive shift away from standard, one-size-fits-all physical therapy and moving toward advanced neuromodulation techniques. One of the biggest game changers is repetitive transcranial magnetic stimulation, or RTMS. It literally uses a localized magnetic field to stimulate the cerebral cortex and force the brain into that highly plastic state.
Just look at the motor recovery data here using the Fugl-Meyer assessment at the 6-month mark. It is crystal clear. Active treatments like RTMS and constraint-induced movement therapy completely blow conventional PT out of the water. Standard PT peaked around a score of 46, but CIMT and RTMS, they push scores up to nearly 57 and 55. Those are massive, statistically significant leaps.
And here is the actual biological machinery in action. By week 12, serum BDNF levels in patients getting RTMS skyrocketed by 88%. I mean, they nearly doubled their baseline levels. The magnetic stimulation is quite literally cranking up the brain's molecular repair factory way past what standard therapy can ever achieve.
But wait, it gets better. It's not just about moving your arms and legs. A massive meta-analysis of 52 randomized trials encompassing nearly 2,500 participants showed RTMS improves almost the whole shebang. We see significant improvements in motor function, language, cognition, swallowing, and even post-stroke mood. The only functional domain that didn't show a significant difference was gait, or walking.
There is one huge caveat, though. Timing is literally everything. Subgroup analyses make it abundantly clear that RTMS has a significantly larger effect on motor recovery when it's applied right away, in that acute or subacute window before the 3-month mark. That's when the brain's plasticity is naturally heightened. If you wait until the chronic phases, well, the gains just aren't as profound.
All right, moving to Section 4, biomarkers and personalization.
Because that window for maximum recovery slams shut so incredibly fast, trial and error is off the table.
We have to know exactly which therapy will work best for which patient on day one. And researchers have cracked how to predict exactly that. They found that simply measuring a patient's baseline BDNF level in their blood right after the stroke is incredibly revealing. Specifically, if they see concentrations over 20 nanograms per milliliter, they can predict a favorable 6-month outcome with roughly 74% sensitivity. That's huge.
So researchers took all this data and built a highly practical real-world application. It's a neuroplasticity-guided stroke rehabilitation protocol, which is essentially a triage system that stratifies incoming stroke patients entirely based on their unique biological profile.
Here's how this step-by-step flowchart actually plays out in a hospital setting. First, you assess the acute biomarkers like BDNF alongside fMRI patterns. Second, you stratify the patient into high, moderate, or low neuroplastic potential. Third, you appropriately match the treatment. Intensive resources like RTMS and CIMT go strictly to brains with high potential that are truly ready for rewiring. Meanwhile, patients with low potential profiles immediately receive vital compensatory strategies and assistive devices. This spares them the physical frustration of treatments their biology currently can't support. Finally, you reassess monthly. It completely takes the guesswork out of rehab.
Let's dive into Section 5, the stem cell frontier.
While RTMS and targeted therapies maximize the brain's existing neuroplasticity right now, scientific evolution never stops, right? Researchers are already heavily investigating what comes next for long-term healing. A recent narrative review on stem cell therapy out of Indonesia captures this profound shift perfectly. For years, the goal was traditional neuroprotection, just trying to protect whatever surviving brain tissue was left. But now, we're transitioning to advanced neurorestoration. We're learning how to actively regrow it.
And it's these specific cellular sources driving the future. Mesenchymal stem cells, neural stem cells, bone marrow mononuclear cells, these are currently being heavily investigated. The goal is to drop them in to promote neurogenesis, generate brand new blood vessels, and modulate the immune response right inside the brain. It is the absolute frontier in biological repair.
Bringing it all home with Section 6, a new era of rehab.
When we bring all this groundbreaking research together, we can clearly see what the future holds for stroke survivors. The old era of treating every moderate stroke with the exact same routine physical therapy protocol is officially obsolete. The evidence confirms that precision medicine, using targeted neuromodulation and biomarker tracking to respect the unique biological reality of every individual brain, is our new gold standard.
So knowing what we know now, that every brain recovers in its own unique way, and that we finally have the tools to measure, predict, and enhance that recovery, it really just leaves us with one question. How fast can we abandon the one-size-fits-all approach and get these personalized, data-driven protocols out of the research labs and into every hospital worldwide? Thank you so much for joining me for this explainer. I hope this completely changes how you view the incredible adaptability of the human brain.